Well, the average was 85 before period 3. Look at that. And then now it's 83 for some reason.
Yeah, still so high.
What does that tell us?
I dropped the class's grade. I dropped the class's grade. That we dropped the class's grade.
Well, we'll talk about that when I pass back the test, because you'll have your current average on there. But first things first. Okay, today we start studying polynomials. So first thing, do we know what a polynomial is? I give you the definition of the polynomial in the notes. Okay, let me ask you. Let me just call on somebody at random. Y equal 2. Is this a polynomial? Mukai?
No.
Yes, it is.
Yes.
F of x. Okay, what about 3x plus 1? You know it. Yes, that's a polynomial. Look at the notes. Anytime you have x to whole number powers, that's a polynomial. See, isn't this like x to the 0? 0 is a whole number, right? Yeah. So that's a polynomial. This is to the first power, that's to the 0 power, so that's a polynomial. What about quadratic functions? Are they polynomials? How about 2x squared plus 3x plus 4? Is that a polynomial? Yes, because it's all whole number powers. What about f of x equal 2x cubed plus 3x squared plus 5x plus 7? Height! All whole number powers, that's a polynomial. See, so we already studied these, right? Last chapter we did quadratic and linear, yeah? Now we do third power. What happens when the power gets 3 and bigger? That's what we're going to do. What about this? F of x equal root x. Is that a polynomial? No, because this is like x to the 1/2 power. Is 1/2 a whole number?
No.
Wait, let me look. No, so that's not a polynomial. What about x? What about 1 over x? Is that a polynomial? No, because that's like x to the -1. Is -1 a whole number? No. So we're going, wait, no. Oh, -1 is an integer, but it's not a whole number now. Woo! Okay, now can I assume we know the basic operations of polynomials? Because we learned them in Algebra 1, right? Addition, subtraction, multiplication, and division. Okay, what about, okay, some of you go, what? Okay, here's 2 polynomials. If I ask you to add them together, can you? I hope so, right? What about subtracting them? Yes, what about multiplying? Okay, I think we better go over that because I remember last year there was, I don't know. So what if you had 2x squared plus 3x plus 4, and I ask you to multiply that by 2x cubed plus 3x squared plus 5x plus 7? What do? Use FOIL. No, FOIL is only when you multiply a binomial times a binomial. I don't even know why teachers teach FOIL because that only works when you have binomial times binomial. That's the only time it works. FOIL is for babies. Anybody ever says FOIL in this class, go home and memorize it, right? So what's the proper term? Distributive property, exactly. Just use the distributive property. So you take the first term and you distribute it. Take the first term and distribute it. 4x to the 5th plus 6x to the 4th plus 10x cubed plus 14x squared. Then you take the second term, distribute it. 6x to the 4th plus 9x cubed plus 15x squared plus 21x. Then you take the third term and you distributize it. 8x cubed plus 12x squared plus 20x plus 28. And then you just add them together. And do you notice how I line up the like terms? Like my Algebra 1 teacher, Mr. Nakano, taught me. You don't have to do this, but if they're all lined up, right? 4x to the 5th plus 12x to the 4th plus 27x cubed plus, what is that? Quick. 41x squared plus 41x plus 28. That's how you multiply polynomials. So was it worth it for me to show you? Because you think we're just going to multiply binomial times binomial in this class? No way. Jose. Okay, now what about division then? You guys know how to divide? Okay, what if I ask you to divide 2x cubed plus 3x squared plus 5x plus 7? I want you to divide that by x plus 1. What did we learn in Algebra 1? What's the dividend? What's the dividend? 2x cubed plus 3. Okay, here, let's pretend. Okay, let's go back to Algebra 1. Okay, you put the dividend here and you make the house. Do I have to explain it in those terms? You make the house. What's Mr. Teskey make the house? No. What did Mr. Teskey say? What about Mrs. Wada? The house. What's the divisor? X plus 1. And then you do long division. This is what it's called, long division. So look at the x. And you basically look at the first term. X goes into 2x cubed how many times?
2x squared.
X times what will give you 2x cubed? 2x squared. Now what do I do with that? You multiply that times the divisor. So you get 2x cubed plus 2x squared. What do you do now? Subtract. You subtract. This is just like regular division, like when you divide regular numbers. It's like the same thing except different. X squared plus 5x plus 7. Is that the remainder? How did every year students ask, how do you know when you hit the remainder? The degree of this has to be smaller than that. What's the degree of this? 1. Is that smaller than 1? No, that's 2, right? So you keep on going. X goes into x squared how many times? X. Then you multiply that times the divisor, so you get x squared plus x. What the heck? Yeah, that's right. And then you subtract. 4x plus 7. Is that the remainder? Are you my mother? No, so you keep going. X goes into 4x how many times? 4. Multiply that times the divisor, and you get 4x plus 4. Subtract. You get 3. Is that the remainder? Yes, because the degree of this, which is 0, is smaller than the degree of that, which is 1. So what's your final answer? If I divide this by this, what's the final answer? What do I write? Okay, you write the quotient plus the remainder over the divisor. This is I don't know why students get confused with this. This is exactly the same thing as dividing numbers. What if I ask you to divide 17 by 5? What do you do? Don't you go 5 goes into 17 3 times, then you multiply that times the divisor, 15. Subtract 2. So what's the answer? Isn't the answer the quotient plus the remainder over the divisor? Right? It's exactly the same thing, except you got variables. I don't know why students get so befuddled about long division. Oh, Mr. Park, that's a lot of work. That's long. Yeah, that's why they call it long division. But last year we learned a shortcut, yeah? For dividing. What was it called? Synthetic division. You guys remember? So it doesn't matter. I'm going to teach you like you don't know anything, okay? So if I divide this by this, yes, you can do long division. Long division works every time, okay? Okay, what about the synthetic division? Now watch what I do. First thing you do is you write down the coefficients of the dividend. 2, 3, 5, 7. If there's a 0, if there's no term there, a missing term, you got to put the 0 in there. You put the box. Now what number do I put in the box? If you're going to divide by x plus 1, what number do I put in the box? -1. Okay, so whatever number is in the box, you're actually dividing by x minus that number. Right? So x minus -1 is like x plus 1, right? Okay, now this is how synthetic division works. You take the first number and you drop it down. And all you have to do now is just multiply and add, multiply and add. So multiply that times the number in the box. -2, add. Multiply that times the number in the box. Add. Multiply that times the number in the box. Add. Okay, there you go. So if you divide this by this, how do you figure out what the answer is? Well, you look at this. What are these called? These are called the depressed coefficients. Okay, you don't have to know the name, okay, but you just gotta know what they mean. So what do you think this stands for? That's the coefficients of the quotient, right? 2x squared plus 1x plus 4. Now, what is the significance of that number? That's the remainder. So when you see this, all you gotta do is write down 2x squared plus 1x plus 4 plus the remainder over the divisor, which is x minus the number in the box. And there you go. So isn't this synthetic division way faster? But you have to be careful how you use synthetic division now, because every year I put this problem on the first quiz, and then students get minus the fatal error. Okay, watch. 2x cubed plus 3x squared plus 5x plus 7. I like, this is my favorite polynomial, this is all prime number coefficients. All over 2x plus 1. Okay, now, if you don't know what to do, don't make up your own now. Okay? Every year students do this. They go, oh, so easy, Mr. Park. 2, 3, 5, 7. I just could put negative half in the box. Fatal error. Minus everything right there. Can't do that. Doesn't work like that. And I'm going to show you why. Okay, let's do long division. 2x cubed plus 3x squared. But that's what we learned last year. No, it wasn't. Make the house. 2x plus, let's do this really quickly. 2x goes into that how many times? Quick. X squared. So that's 2x cubed plus x squared. Subtract. 2x squared plus 5x plus 7. 2x goes into that how many times? Alright, so 2x squared plus x. Subtract. 4x plus 7. Ooh, 7. 2x goes into that how many times? 2. So you get 4x plus 2. Subtract, you get 5. So the answer is x squared plus x plus 2 plus the remainder over the divisor. That's the correct answer, right? Because long division always works. Okay, now let's do synthetic division. Drop the 2 down. Can you see it's wrong already? It's not even correct. This stands for 2x squared. It's wrong. That's why fatal error. When you do synthetic division, you're dividing by x minus the number in the box. So if there's a number in front of the x besides 1, if the coefficient is not 1, you gotta make it 1. So how do you do that? How do I make that a 1? Just divide it by 2. I noticed yesterday's test, a lot of you just do stuff. If you have an equation, you can do things to both sides of an equation. But if you have just an expression, you can't just multiply it by 2, because it changes the value. Just like if somebody asks how old you are, what do you say? I'm 32. I just multiply it by 2. No, you can't do that. It changes the value. If you have an equation, you can multiply both sides by 2. But if you have is this an equation? No, an equation has an equal sign. There's no equal sign here. So you have to do things like I can multiply top and bottom by 1/2. That I can do, right? But this is not an equation, so you can't just multiply the bottom by 1/2. It changes the value. Okay, so before you even start, multiply top and bottom by 1/2. Okay, are we smart enough to do this in our head? So if I multiply the top and bottom by 1/2, what's going to be the coefficients now? 1, 3 halves, 5 halves, 7 halves. Put the box. Then the bottom is going to be x plus 1/2, right? So now what do I put in the box? If it's x plus 1/2. Now you can put negative half in the box. Now you do synthetic division. Drop the 1 down, multiply. Multiply. If you cannot multiply by 1, just go home, cook, right? Don't cook, right? Just go home. Negative half, add.
1 more. 2. 1.
2. Who said 2? 1. Multiply. Add.
2.
Multiply. No, multiply. Look. Add. No, 5 halves. So the answer is going to be x squared plus x plus 2 plus 5 halves over x minus the number in the box. That's your answer. Now, can you see that's exactly the same as that now? But of course, some of you, like on yesterday's test, some of you are leaving fractions within fractions. That's automatic -1 for simplifying. You cannot have a fraction within a fraction. So you have to simplify that. So how do you simplify when you got fractions within fractions? Multiply top and bottom by the LCD, which is 2, and then you get 5 over 2x plus 1. That's it. It's the same answer. Oh, so Mr. Park, synthetic division is way faster. Yeah, but you have to use it correctly. You cannot just make up your own. Okay, let me give you another problem. Okay, so that's just the basics, okay? Adding, subtracting, multiplying, dividing. Operations on polynomials. Okay, now let me give you another problem. F of x is equal to 2x to the 5th minus, give me a single digit number. 7x to the 4th plus 1.
9.
2. Pick up, okay, 9x cubed minus 1, okay? Go, 1, go to 1. Be mundane.
1.
Minus
1.
Okay, no. Okay, here. Compute f of 7. Go. Okay, let's say we're in a Turkish prison. We're all gonna compute f of 7. Whoever's last place is gonna be dragged through the streets or whatever. So, how are you? You want to be in the top, right? So, how are you going to do the problem? What are you going to do? Plug in 7. Okay, no, let's plug in 7. No, let's go. Okay, let's go. What did we learn last year? This is review. Okay, 7 to the 5th. 7 to the 5th, somebody. Window. Do you have a secret technique for this one too? 7 to the 5th. No, you do. Okay, think. 7 to the square is 7 cubed is 7 to the 4th is. Well, you're supposed to know your cube numbers up to 10. So, right? Obviously, so 7 cubed is 343, right? What's 7 to the 4th? Try 7 to the 4th. Quick. Redeem yourself. Okay, no. Put down that pencil. Okay, 7 to the 4th. 7 times 7 times 7 times 7. Isn't that 49 times 49? Duh. No, what did you guys learn in elementary school? If you have to do 49 squared, what do you think in your head? 50 minus 1 squared, right? Yes or no? Is 49 50 minus 1? Okay, and then just use this property. A minus b squared is equal to a squared minus 2ab plus b squared. So what's 50 squared? Everybody can do that, right? 2500 minus 2ab, which is, are you serious? 2ab is 100 plus 1. Anybody can do that in their head, 2401, right? Okay, but now you're gonna that's only 7 to the 4th. Now you're gonna do 7 to the 5th. So multiply 2401 times 7 and then times that by 2. I'm still waiting. And then we're gonna plug it in here, here, and here. There's gotta be a better way, Mr. Park. This is too long. Yes, what did we learn last year? You do synthetic division. What? Okay, so 2, negative 7. Look, I'm teaching you like you don't know anything. You write the coefficients of the polynomial, you do synthetic division. So, if you want to compute f of 7, what number do I put in the box? 7. Okay, let's do synthetic division. Drop the 2, multiply. Add. Multiply. Add. See, you pick, whoever picked these numbers are bad numbers. Okay. 7 times 58. Okay, no, let's try and do that in our head. Think of that as 60 minus 2. Here, 7 times 60 minus 2. You guys gotta practice. 420 minus 14. 42? What? No. Maybe if I write it out. 420 minus 14. What's 20 minus 14? Let me get my calculator. Okay, 406. Add. These are bad numbers, Mukai. But still, even though they're big, no, it's still better than doing 7 to the 5th power, right? Some of you are still befuddled about that. No, you can do this. What is 400 times 7? 2800 and then 5 times 7. So 2835. Who picked these? That's what I want to know. So 2836. Okay, times 7. So this one we have 2 carry 4, 5 carry 2, carry 5, 19, 8, 52, add, so 19, 8, 51. That's the remainder. So you know what the answer is? The answer is 19,851. Why is the remainder the answer when you plug in 7? Why is the remainder f of 7? Okay, look at your notes. It's right there in the notes, people. There's only 2 theorems we're going to learn today. The remainder theorem. Okay, now last year, yes or no, did you learn the remainder theorem and the factor theorem? That's the 2 major theorems you have when you do synthetic division. So, if you do synthetic division by a number, the remainder is the same thing as taking this number and plugging it into the polynomial. That's what the remainder is. That's what the remainder theorem says. So, when you have a problem like this, you have to ask yourself, is it easier to plug in the number, or is it easier to do synthetic division? You do the easier one. So tonight, there's like a mixture. You have to decide which one's going to be easier. Okay, next problem. Is x plus 3, no you fool, x minus 3 a factor of x cubed minus 6x squared plus 11x minus 6, question mark? How do you tell? You do synthetic division, that's right. So you write down the coefficients, 1, negative 6, 11, negative 6. Okay, what number do I put in the box? 3. X minus the number in the box, right? So let's do synthetic division. 1, multiply, add, multiply, add, multiply, add. Oh, what happens when the remainder comes out 0? What did we learn last year? If the remainder comes out 0, that means x minus the number in the box is a factor. So is x minus 3 a factor? Yes, because the remainder came out 0. So, and that's probably the most important reason why we learn synthetic division, so we can factor polynomials of degree 3 and more. Okay? So, if I factor this, if I ask you to factor this, you go x minus 3, because it's a factor. What's the other factor? Yeah, you look at the compressed coefficients. What does that stand for? Are you serious? X squared minus 3 and x plus 2. Once you get it down to a quadratic, then you can either factor it or use the quadratic formula, right? Because if you had an equation, like what if I ask you solve this equation, how do you solve equations when the degree is 2 or more? You make one side 0 and you factor the other side, right? So we have to learn how to factor when the power is 3 or more. And that is synthetic division. Okay, does this factor anymore? Yeah, so that's x minus 1, x minus 2 equals 0. So your solutions for this equation would be x equals 3, 1, or 2. That I know you guys learned last year, right? Yeah, so that's why we use synthetic division. Now, you don't have to use, in fact, when was the last time this happened? In 1999, somebody in this class, they said, Mr. Park, I don't need synthetic division. I can just factor that all the time because in Algebra 1, we learned how to do factor by grouping. And I know Mr. Rubash likes to do that a lot, yeah? Who had Mr. Rubash? He likes to do factor by grouping, yeah?
Yeah.
So here, let me show you. How do you factor, let's just do this for fun. How do you factor this by grouping? Should I just group it 2 and 2? That's the easy one. Well, let me ask you this. Does 2 and 2 work? I don't know, Mr. Park. Look at the coefficients. Is the ratio of the coefficients this to this the same as that to that? No, so no, 2 and 2 is not going to work. If they have the same ratio, then it works. But the harder factor by grouping, what you have to do is you have to do things. You have to like borrow. Like what? Anybody? Like you have to split up this negative 6x squared into like 2 things. Yeah, so you can factor by grouping. So how do you think you want to split up that negative 6x squared? Anybody? How about negative x squared and then minus 5x squared plus 11x minus 6? Because isn't negative x squared minus 5x squared negative 6x squared? Now, how do you know if that's going to work or not? Well, you got to try it. Okay, let's group the first two terms together. Go. What can I take out? What's left? Okay, I can take out a negative sign there, and you get 5x squared minus 11x plus 6. Can that be factored? Minus 5x and x, what? 3 and 2, 6 and 1, what do we got? 6 and 1? 6 and 1 minus minus, okay. Does that work? Yes, because you have the same factor here and here. If you have the same factor here and here, you factor it out, which is x minus 1, and what's left? X squared minus this, which is minus 5x plus 6. And then now you got x minus 1 times x minus 2 times x minus 3. That's factored by grouping. This is the part that's hard. Yes, and that's why we have synthetic division. See? If you can think up here, then factor by grouping is fun, yeah? But for most people, factor by grouping is not fun, and that's why we have synthetic division. It's like a mechanical way of doing it. You don't have to think as much. So in this chapter, if you like factor by grouping, you don't even have to do synthetic division. Just factor by grouping all the time. Take the challenge. Okay, so tonight's homework should be easy. It's like, well, everything in this chapter is review. We're not learning anything new in this chapter. We just got to hone our skills. Okay, let's talk about the test now. Did anybody here not take the test? Okay, you can just take your stuff and go already.